Let's try to solve this problem here. Stationary waves are set up in the tube closed at one end and another tube open at both ends. So we have two situations here. One is a closed pipe, one is an open pipe. Both tubes are length of 34 cm. So we know that what's the same between these two tubes? They have the same length. Okay, so draw diagrams showing the stationary wave set up in both tubes for fundamental mode and also the second overtone. So there are two stationary waves that we need to sketch for each tube. So there are 4 diagrams that we need to sketch actually. So let's label everything clearly so we don't miss out any diagram. For question A, you need to do it once for tube close at one end, then after that you need to do it also for another tube which is open at both ends. Okay, but what's the same between the two? They should have the same length for their tube. So I'm going to sketch same length. Okay, let's hope that my hand is working fine today. Okay, one more. Okay, all of them should have the same length. So if I label them, they should all have the same L. Okay, L, 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 L. Okay, now what do we know? I'm going to sketch one for the fundamental mode, one for fundamental mode, the other one will be your second harmonic, second overtone, sorry. Second overtone, second overtone. Okay, so just to make sure that I'm not missing out any diagram, I sketch out the pipe first, or the tube first. Okay, so fundamental mode, close at one end. Yeah, cannot forget. Yeah, if it's closed at one end, you have to close it. Okay, so we know that for fundamental, it's the simplest standing wave that can be produced. This end will be closed, so particles cannot vibrate freely. It's a node over here. The other end over here, particles are allowed to vibrate freely, so there's an antinode over here. Node can stay beside antinode, there's no problem. We are not putting node side by side, we are not putting antinode side by side. So this is logical. This is the simplest wave that can be produced in a closed pipe. Okay, so if I wish to label it, I can label it as the distance between the N and A will be lambda over 4. Okay, and N or AA is lambda over 2, so NA will be lambda over 4. Okay, so that's the most fundamental tone or fundamental mode that we can sketch. Then we know that node is in the middle, antinode is at its maximum amplitude, so you can sketch the graph to be something like this, okay, and this one probably needs a bit of fix, something like this. Okay, great. Okay, so this is for fundamental mode for closed pipe. Let's do it for open pipe. For open pipe, both ends particles are free to move, so both ends should be antinode. Antinode cannot stay side by side. We need to put in a node in between to make it logical. So this will be the arrangement for a open pipe. We know that the distance between A and the next A will be lambda over 2. So this one can label as lambda over 2. And if you want to sketch the diagram, antinode's maximum amplitude, node 0 amplitude. So maximum amplitude. So if you sketch it, it will be something like this. Okay, so this is the tube at both open at both ends for fundamental mode. Okay, next we move on to overtone. Again, when you look at overtone, you have to be a bit more careful, because overtone is how many leaps you are leaping. For tube that are closed at one end, according to the lecture, I hope that you have watched through the lecture, you know that the frequency can only be odd harmonics only. You cannot have even harmonics for closed pipe. So the next harmonic after F1 will be F3 actually. There's no F2 because even harmonics are not achievable in a closed pipe. So for a closed pipe, you can only have odd harmonics. So it's F1, F3, F5, F7, and so on. Okay, but you're looking for second overtone, means that you only want to leap twice. So first time you leap here, second time you leap here. Okay, so that means by your N is equals to 5. You are going to sketch a second overtone that has N is equals to 5. Okay, N is equals to 5. How do you sketch it? Okay, the most simplest standing wave is like this. Okay, but in order to sketch the N is equals to 5, okay, let me talk about N. When you see N is equals to 1, that is the most basic standing wave that can be produced. So you can see that the graph looks something like this. Okay, if it's N is equals to 3, that means by these things we have to multiply by 3. So that means you're going to see it once, you're going to see it twice, you're going to see it thrice. Sorry. Okay, so this is what you should be looking forward to. Okay, so we know this will looks like N, A, N, A. Okay, so we can sketch N, A, and A. N, A, and A, so note is over here, note is over here, antinode, 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 antinode. So if we sketch our diagram, it will be something like this. This will be the fifth harmonic. Oh, we want N is equal to 5. I'm sorry. Mess up. Sorry, I thought we want N is equal to 3, but we are looking for N is equal to 5. My mistake, everyone. So let's reverse it a little bit. Okay, N is equal to 5 means by the pattern, we have to multiply 5 times. Okay, this pattern here we have to multiply 5 times. So N is equal to 5. You see it happen once. You see it happen twice. The third time you are going to see it. The fourth time you are going to see it. The fifth time you are going to see it. Okay, this is how the pattern should looks like. So there's node, antinode, node, antinode, node, antinode. So NA, NA, NA. So you can put it in NA, NA, NA. Okay, node is at the middle. Antinode, you're at your maximum. Okay, so now if you sketch, maybe something like this. The other side, something like this. Okay, so this will be your second overtone or the fifth harmonic for closed pipe. Okay, we should also label as well the distance between N and A. It's lambda over 4, so this is lambda 5 over 4, lambda 5 over 4, lambda 5 over 4, lambda 5 over 4, and lastly lambda 5 over 4. Okay, so usually I'll label it just to show that how many times does the fundamental pattern repeats. Okay, in this case it repeats 5 times. Okay, for tube open at both ends, which is open pipe, we know that all harmonics are accessible, so we can do F1, F2, F3, F4, so on. But you know that you want second overtone, so you only leap twice. So 1 time, 2 times. So you know that F3 is what you want, N is equals to 3. So if we say N is equals to 3, that means by your fundamental pattern, Just now we already sketched a fundamental pattern. It looks something like this. If n is equal to 3, means by this pattern should repeat 3 times. So it repeats once. The second time it repeats. The third time it repeats. Okay, so you should see A, N, A, N, A, N, A. Okay, so let's label it A, then you have your N in the middle, then you have an A in between, you have your AN in between. Okay, so this will be how it should look like. At antinode, maximum, at node, in the equilibrium. Okay, put in dots inside. So we sketch antinode, node, antinode, node, antinode, node, antinode. The other side, antinode, node, antinode, node, antinode. So this is how a graph should look like. So distance between A and A, you can label it as lambda 3 over 2 because it's a third harmonic. This one is also lambda 3 over 2. This one is also lambda 3 over 2. Okay, done. We are done with sketching these 4 diagrams to show the stationary wave set up in both tubes for fundamental mode and second overtone. Okay, so next let's move to question B. Question B, calculate the frequency of the fundamental mode and the second overtone for the open-end tube. So they want to know the frequency. Okay, again, if they want to know the frequency for question B, it's always V is equal to F lambda. It has never changed. Okay, so right now for fundamental, let's put it as 1. Our focus is the frequency, so let's shift around the equation, lambda 1 over here. Let's determine the relationship for fundamental for open-end tube. This is open-end tube fundamental. We see that L is equals to lambda over 2. Okay, L is equals to lambda over 2. You can put in lambda 1 over 2, no problem. So lambda 1 is equals to 2L, and therefore rearrange the equation to be V is over 2L F1. Okay, so the speed of sound is 330. The length of the pipe is 0.340. Okay, all of the information are provided up here. 34 cm, change to meter, speed of sound. So from here you can find the fundamental frequency to be equals to 485.29 Hz. Okay, that's the frequency for fundamental mode. Now let's look at frequency for the second overtone. Just now already mentioned second overtone, your N is equals to 3. Yeah? So if you write N is equals to 2, then that is where you get things wrong. Okay, second overtone, your N is equals to 3. So you have to be very careful. Write it as V is equals to F3 lambda 3, not F2 lambda 2. If you write 2, wrong. Okay, overtone, always be very careful. So focus again is F3, so bring shiftings around, V over lambda 3. Let's find the relationship between these two things. Length is equals to 3 times of lambda over 2. Okay, length is equals to 3 times of lambda over 2. So shifting around to get the subject as your wavelength. So this will be 2 over 3 times L. Okay, so now we can bring this in over here. This will be 2L over 3. Now you're just left with substitution. Did I do it right? No, I do it wrongly. Sorry, it's my 5th video continuously. Okay, so lambda 3 is down here. We replace lambda 3 here with 2L over 3. Now we proceed to do substitution. This will be 330 divided by 2 times 0.430 divided by 3. Okay, so if you proceed to calculate it, I believe you get 1455.88 Hz. Okay, this is F3. But of course, you can find F3 using a simpler method, which is just taking the fundamental frequency times 3. Okay, so you take 485.29 multiplied by 3. I believe you end up with the same answer, which is 1455.88 Hertz as well. So you can do it using the long-winded method, method 1. Okay, or you can do it using method 2 by just taking the fundamental frequency and multiply it. Okay, so I'll split here because this one is for n is equals to 1, this one is for n is equals to 3. Okay, so again, it looks very similar to the question. You just use v is equals f lambda, but you need to figure out the relationship between the length of the pipe and the wavelength. Once you're able to figure that out, the rest is just substitution. Okay, so that's it for this question. Thank you very much.